For this problem, give it a try on your own first before you continue the video, and whenever you're ready, we're going to go over this problem together. In this scenario, we're still working with the equation, or base everything off of the equation, work equals rate times time. And we say that it takes 2.5 hours longer to mow a football field than it does a more experienced employee. And together they can mow the grass in 1.9 hours, and we want to find out how long it takes each person individually to mow the lawn or mow the field. And in this case, if we want to figure this one out, we can again start off by setting up the variable. And here, because we are looking for how long each person would take, and I'm going to let the person taking the shorter time be t over here, be the variable. So let's say we can say it takes, I'm just going to write a sentence here. It takes the more experienced employee, let's say H hours, to mow the field. And I chose to use the more experienced employee's time as the variable because I want to work with addition instead of just subtraction when I define the other time over here. So if I know the hours it takes one employee is 2.5 hours longer, then I can say the less experienced employee would take H plus 2.5 hours. And this is a completely personal choice as to which one you want to define as the base variable, and just use operation based off of that over here. So we have these two quantities already, and I'm going to kind of complete the table off of this as well. So I'm going to use M for more experienced and L for less experienced. So for the more experienced and less experienced, they're both mowing one single field, so the work is always one. And for the time, I just defined for the more experienced employee, it would take H hours, and for the less experienced, it would take H plus 2.5 hours. And right away, we know that we can find the rate. The rate is a quotient between work and time, so work divided by time is rate. And similarly, 1 over H plus 2.5 is going to be the rate of the less experienced employee. And then if they work together, they are still mowing the same field, so the work is still one that didn't change. And I also know that they can mow the field in 1.9 hours. That's given, and therefore I know the rate is 1 over 1.9 in this case. And based off this information, again, the relation between all these quantities is that if I want to find the rate when they work together, it's a sum of the two individual employees. So I can set up the equation to be 1 plus H plus 1 over H plus 2.5 is equal to 1 over 1.9. And that's how we want to set up the equation. And in this case, if I want to solve this equation, I still want to use LCD, and it's a little bit more involved because I need to use a product of all three. They're not multiples of each other anymore in this case. So I need 1.9 H times H plus 2.5, and I have to multiply that to everything on top. So I'm basically just going to replace all the numerators with the LCD. And on the right hand side, I also have this on the numerator. So I'm just writing out all the numerators together. And then in the denominator, I had H plus 2.5, and finally I had 1.9. So that's what we should have if we multiply the LCD across the board. And then we can do some cancellation. We get H and H cancel out, h plus 2.5 cancel out here, 1.9 cancel out here. So as a result, I get 1.9 h plus 1.9 times 2.5 over here, plus 1.9 h, then this is equal to h squared plus 2.5 h. I just went ahead and distributed things wherever I needed to, because I know I have to simplify the expression next. So now let's combine some like terms on each side just to make sure each side individually has been simplified as much as possible. And on the left hand side we have 1.9h plus 1.9h, which is equal to 3.8h, plus 1.9 times 2.5 is 4.75, and this is equal to h squared plus 2.5h. And once we have this form, we have a quadratic equation to solve. And to solve this, we would want to put all the terms on one side and just set it equal to 0. So I'm going to go ahead and subtract 3.8h and subtract 4.75. So I have 0 on the left, h squared minus 1.3h minus 4.75 is what I would end up with in this quadratic form. And once we get to this point, we can see this is a problem that we can either use quadratic equation or we can use a graphing facility to solve over here. And in this case, depending on what you're allowed to do, if we're just going through the process to understand the applications. So I'm just going to go ahead and use a graphing facility to help us solve this problem. And in this case, if we go ahead and plot this in GeoGebra, this is the function that I have. And once we plot it, we can see there are these intersects over here with where it hits the x-axis, and that's what we want to look for. And I'm going to go ahead and try to find the intersection between the function and the x-axis. So that's where we can find the zeros. And in this case, we found the two x-coordinates are over here. We can get h is equal to 2.92 or h is equal to negative 1.62. And based on our context, we know that h defines the number of hours, so this answer is extraneous solution in our context, because we can't really work out this equation to make sense of this content. And given that, we would know h is equal to 2.92 hours, and therefore we can find for the less experienced employee, h plus 2.5 is equal to 2.92 plus 2.5, which is equal to 5.42 hours. So we can say that it takes the more experienced employee (2.92 hours) and the less experienced employee a total of 5.42 hours. And based on this, that's how we can answer this question.